May 2022, the day when the largest astronomical event took place. For the first time in history, scientists obtained a photo of the supermassive black hole Sagittarius A lurking in the depths of the Milky Way, 27,000 light-years from Earth. The importance of this image doesn't even need to be mentioned. It's obvious. First of all, the photo serves as proof that our galaxy really does contain the same kind of object as those found at the centers of other similar star clusters. What can we confidently identify in this image? What other incredible images have changed our understanding of galaxies? And what in the universe exceeds the size of our Milky Way by dozens or even hundreds of times? Hubble. With the development of technology in the field of astronomical research, it is becoming possible to observe objects that scientists could not even dream of seeing just 10 years ago. Thanks to this, a kind of ranking of giant galaxies has appeared, as well as the first relatively clear image of a black hole in our galaxy. Why was it previously impossible to observe the supermassive black hole Sagittarius A? To explain this omission, let's turn to terminology. What is Sagittarius A from an astronomical point of view? First of all, it is a compact radio source that emits in the X-ray, infrared, and other ranges. It is also a supermassive black hole of enormous density. Considering the small size of the object and its invisibility, since even photons of light cannot escape the maw of the insatiable funnel, unprecedented optics had to be used for observation. And finally it happened. A photo of the phantom, located at the center of the Milky Way, was taken by a telescope with the historic name Event Horizon Telescope. This is a global project, a worldwide network consisting of several interferometry stations scattered all over the Earth. The capabilities of this array of telescopes have been significantly expanded compared to previous projects. What does this mean in practice? The 8 observatories that make up this conglomerate essentially form a powerful antenna the size of the Earth. Thus, it can detect extremely small objects, of course, on the scale of the universe. In astronomical terms, we can observe celestial bodies that are only a few dozen micro-arc seconds in size. For comparison, let's suppose we left an ordinary bagel at the bottom of one of the moon's craters, or seas. Using the gigantic antenna of the Event Horizon Telescope, observers would be able to clearly see this pastry without leaving Earth. What does the massive and super dense black hole at the center of the Milky Way look like? The image shows background light surrounding the object with a sparkling halo. This matches our understanding since Sagittarius A is indeed surrounded by a dense and hot gas cloud with a diameter of almost 2 parsecs. Where did this gas come from? It consists of matter that, roughly speaking, the black hole feeds on. The nearby stars are the ones supplying it. By the way, observations have shown that the stars orbit the black hole at incredible speeds, reaching up to several tens of % of the speed of light. But with such advanced optics, can we look much farther than the boundaries of our galaxy? Not only can we, but we must. After all, the universe hides countless secrets. For a long time, the Milky Way was thought to be a large galaxy. Its diameter is about 100,000 light-years, although some scientists give a different figure, 1,000,000 light-years. As you know, everything is understood by comparison, so our star cluster has lost its esteemed status. At the moment, 5 giant leaders have been identified, although we suspect that the list is far from complete. The galaxies we're about to talk about are many times larger than the Milky Way, and they also impress with other amazing features. 5th place goes to the galaxy with the codename 3C348. At its center, There is also a super-dense radio source, a black hole called Hercules A. The difference with this object is that it is 1,000 times more massive than Sagittarius AA, weighing 4 billion suns. Overall, this is one of the most impressive black holes known to science. To detect the mentioned galaxy, the Event Horizon Telescope was not needed. The good old Hubble did an excellent job with this task, but the monstrous radiation emitted by this object was detected using a very large antenna array, a group of radio telescopes located in New Mexico. Astrophysicists are confident that the hellish jets emitted by galaxies appear precisely because of their black holes, although these phenomena are still very poorly studied. Where is the elliptical galaxy 3C348 located? Believe me, it's very far away, 2 billion light years from Earth, and yet we were lucky enough to notice that this object emits 1 billion times more radio waves than our Sun. At the same time, it is one of the brightest extragalactic radio sources in the observable sky. Among other things, the relativistic jets emitted by the galactic center reach a distance of 1 million light years. The name of the galaxy and the black hole, Hercules, at its center comes from the constellation of the same name located nearby. It would seem, what could be more monstrous than the galaxy we've just seen? However, in fourth place in our ranking is an even more astonishing object, with the codename Index Catalog 1101. The distance to it is over 1 billion light years. The elliptical supergiant galaxy, located in the constellation Virgo, held the laurels of leadership for a long time. And indeed, what in the universe could be more grandiose? But let's not rush to conclusions. So Index Catalog 1101 is one of the galaxies in the massive Abell 2029 cluster. The diameter of this giant is 6 million light years, and in terms of width, this galaxy still leads among other stellar conglomerates. The other parameters of Index Catalog 1101 are no less impressive. Let's take the Milky Way as a benchmark. The mentioned galaxy is 20 times more massive and 60 times larger than ours. Tell me, can you imagine such scales? If it were in the place of the Milky Way, it would easily swallow the Andromeda Nebula, both Magellanic Clouds, and, for dessert, the Triangulum Galaxy. How did Index Catalog 1101 grow to such implausible sizes? Astrophysicists believe that this was preceded by multiple collisions and mergers of several large galaxies. Interestingly, in the 18th century, when it was discovered, the object was mistakenly thought to be a nebula because of its incredible size. So what cosmic monster takes third place? Meet the lenticular radio galaxy, Uppsala General Catalog 9555, located 820 million light years from our planet. Astronomers are also confident that this object was formed as a result of the merger of smaller star clusters. Would you like to know the size of this monster? Please. The galaxy has a diameter of almost 8.4 million light years, which is 83 times larger than the Milky Way. The object with the index Uppsala General Catalog 9555, discovered by the somewhat outdated low-frequency array optical system, is itself part of a densely populated cluster of similar cosmic giants. Taking into account the combined results of research and observations, astronomers are confident that at the center of every galaxy, there is a massive radio-emitting black hole. This is similar to the Milky Way, and it's Sagittarius A. Next, we ask those who are faint of heart to stop watching the video, because true masters are about to take the stage on the cosmic arena. If some space shuttle decided to fly through Galaxy 3 C236, it would take 15 million light years, or 4.5 megaparsecs to do so. That is the diameter of this star cluster. The radio galaxy belongs to the Phaneroff-Riley Class II, and it is one of the largest discovered so far. Predictably, at its center there is an ultra-compact radio source that is a black hole which actively emits high-energy jets. The length of the deadly jets reaches almost 15 million light-years. How fortunate it is that a more balanced object is hidden in the heart of the Milky Way. Otherwise, the existence of humanity could have been called into question. Which telescope was involved in the discovery of Tri-C 236, the same low-frequency array? During the observation, scientists noticed several strange hot regions of unknown origin on the relativistic jets. Where did they come from and what could they mean? Several hypotheses have been proposed, including the idea of a disruption in the process of matter accretion. And here comes our champion. The cherry on top is the largest galaxy in the universe that we've ever been able to observe. Its name is Alcyone. The cluster was discovered in February 2022 with the object's diameter being 5 megaparsecs, or 16.3 million light years. Next to this monster, our own Milky Way would look like a tiny dot. Such gigantic galaxies are an unsolved mystery of the macrocosm. How do they form? What causes them to reach such incredible sizes? Is it really just that some galaxies merge with each other, or is the answer something else? These questions remain unanswered. Almost every giant is characterized by the emission of killer relativistic jets, which once again confirms the conclusion about the presence of active black holes in the central regions of stellar conglomerates. It is noteworthy that almost all of the mentioned galaxies are quite old, so we will inevitably find other giant structures as well. This is just the beginning of an exciting search. Is that good or bad? Astrophysicists are thrilled. After all, studying massive clusters of stars, especially those with active black holes, will provide the key to understanding the mechanics of many processes in the universe that, unfortunately, are still hidden from us. What thoughts come to your mind when it comes to the human population? Isn't it true that sometimes you have mixed feelings? On one hand, during its existence, humanity has achieved significant progressive heights. We have learned to cure deadly diseases, created many intelligent machines, reversed the flow of rivers, turning barren lands into blooming gardens, conquered mountain peaks, and explored the ocean floor. On the other hand, humanity has not mentally advanced far from barbarian tribes, constantly attempting to seize foreign territories, killing in the name of imaginary gods, and acting from a position of strength. Perhaps this is yet another answer to the well-known Fermi paradox. They are not here because no one wants to deal with us. After all, the vast majority of Earth's inhabitants are too aggressive and primitive. It may take centuries to correct this aspect. Meanwhile, progress is relentless. It doesn't care about moral doctrines. That's why we persistently continue to search for others like us in the cold cosmos. Recently, amazing news spread around the world. Another planet was discovered near the closest star to us, Proxima Centauri. Maybe life is already stirring there? Proxima Centauri is located about 4 light years away from Earth. Apparently that's why it's called that, since Proxima means the closest in Latin. The star is quite modest in size, with a diameter only about 1.5 times larger than Jupiter. If you compare Proxima Centauri to our Sun, it's 8 times smaller in mass and 7 times smaller in diameter. Overall, the system consists of 3 stars. 2 of them are located quite close to each other. But right now, Proxima is almost 2 billion kilometers away from the other members of the stellar trio. The largest one, much bigger than our Sun, is Centauri A. Its closest partner is about half its size, and Proxima is the tiniest compared to its distant neighbors. That's why it's impossible to see the star without special optics. What does the discovery of this small star, which happened, by the way, in 1915, give us? First, previously, the closest star to the Sun was considered to be the huge Centauri A. Second, over time, a planetary system was discovered near Proxima Centauri. Naturally, as always in such cases, astronomers began to speculate whether there is biological life on at least one of these planets. This seems unlikely since Proxima Centauri is a red dwarf, a highly unstable star whose life is constantly accompanied by bursts of incredible amounts of energy that destroy everything in their path. It is important to understand that the existence of a red dwarf is pure hell, both for the star itself and for the surrounding objects. Proxima Centauri belongs to the long-lived stars. Red dwarfs live for tens of trillions of years, remaining on the main sequence much longer and not transforming into other types of stars. This means that once life develops on planets near such stars, it has a certain chance for further progress. That's probably where the good news ends. Red dwarfs are very dim. For example, Proxima Centauri's luminosity is 10,000 times less than that of our Sun. That means a potential exoplanet would have to be close enough to the star. Otherwise, it simply wouldn't get enough light and heat for life to emerge. Such a condition leads to the following problem: tidal locking. What is that? When a less massive body gets too close to a larger one, it is forced to always face it with the same side. A similar phenomenon can be observed in the solar system. For example, consider our constant companion, the Moon. What physical conditions would the surface of a tidally locked planet offer? On one side, oceans of lava would boil, while on the shadowed hemisphere, an eternal ice age would reign. But what is the main obstacle to the emergence of life on planets orbiting red dwarfs? It's the excessive activity of such stars. Sterilizing radiation flares are capable of destroying any sprouts of life at the very beginning. What can this be compared to? Imagine if our Sun turned into a red giant for several thousand years, and then later returned to its original size. Guess what would happen to the Earth during that period? Basically, a red dwarf is like a lady with an unstable psyche during a hormonal imbalance. It's impossible to predict when the next destructive flare will happen. But that's all theory, so what about in practice? Because of its relative proximity to us, Proxima Centauri and its planetary system have been studied comparatively well. Moreover, new details are being discovered every year. It is known that in the so-called Goldilocks zone, the habitable sector of the star, several planets are orbiting. Discovering such small objects was very difficult for scientists. To achieve this, all known indirect observation methods had to be used. In particular, the radial velocity method was actively employed. What is the principle mentioned? The fact is that planets, even the smallest ones, influence their stars by shifting their center of gravity. This is noticeable thanks to the Doppler effect. Thus, astronomers, by observing the shift of spectral lines with a high-precision spectrograph and measuring velocity deviations, discovered a planetary system near the red dwarf Proxima Centauri. The Very Large Telescope and the specialized espresso spectrograph were used for the observation, but despite the high precision of the smart equipment, scientists had doubts for a long time. Perhaps these are just periodic changes in the star's luminosity. The concerns turned out to be unfounded, so the catalogs were updated with another object in the star system, Proxima d. At the moment, 3 planets of different sizes and characteristics have been discovered near Proxima Centauri. The last one, as already mentioned, was detected in February 2022. This was done by a group of astronomers from the European Southern Observatory, located in Chile. Scientists announced the existence of Proxima S 2 years earlier. What does the newly discovered planet Proxima d look like, according to astronomers? It orbits almost right next to its parent star, just 4 million kilometers away. That's 10 times closer than Mercury is to the Sun. Accordingly, a year on Proxima d is only 5 days long. Its mass is extremely small, about a quarter of Earth's, which makes Proxima d the least massive of all discovered planets of this type. Thus, it is a small object with insignificant mass. Proxima b and Proxima c, its neighbors, orbit slightly farther from their star. On the first, a year is 11 days. On the second, 5 Earth years. Is Proxima d located in the habitable zone of its star? There is an active debate about this, but most scientists agree that it is not. It orbits too close to the red giant. The surface temperature is estimated to be around plus 87 degrees Celsius. Could this become an obstacle to the development of life on the planet? If we remember that even in boiling terrestrial geysers there are extremophile bacteria, then probably not. But the main thing that astronomers want to convey to the world is the following. There is a whole host of different worlds orbiting our nearest star, from super-Earths to tiny, almost weightless planets. This inspires optimism and the desire to continue searching. Now, for the most interesting part, have there ever been any signals detected coming from within the Proxima Centauri star system? It turns out yes. This happened in December 2020. The signal was immediately dubbed BLC-1 and began to be studied meticulously. The unexpected greeting from Proxima Centauri was detected with the Parkes Observatory telescope in Australia. The corresponding program started back in 2015, and its goal was to search for extraterrestrial signals. It's clear that the first object astronomers targeted was the closest star to us, Proxima Centauri. After 5 long years, the result was obtained. A signal with a spectral width of 1 gigahertz was considered impossible to be produced by an astrophysical object of natural origin. In addition, scientists claimed that the source of the signal could not possibly be located on our planet. Its intensity changed, which most likely indicated the orbital rotation of the object emitting the signal. The transmission of the alien message lasted for about 30 hours. Astrophysicists also ruled out random echoes from artificial satellites or passing airplanes as the cause, since this frequency is not used by those objects. So does this mean that for the first time since the famous WOW signal, we've once again detected sounds from an advanced civilization? Unfortunately, no. Later on, scientists concluded that BIL Psi-1 actually has an earthly origin. Perhaps the process of intermodulation is to blame, during which 2 frequencies mix, producing radio interference. What a disappointment. It makes you want to ask once again, so where are they all? Is there any plan for further exploration of the Alpha Centauri star system? In the distant future, yes, an interstellar shuttle may be sent to our closest neighbor. However, the journey would take more than 1,000 years, unless, of course, a non-nuclear propulsion system is used. For comparison, the Voyager probe, traveling at 17 kilometers per second, would take about 74,000 years to reach the star. But who knows, if progress continues to develop relentlessly, then by using a nuclear pulse engine, the flight to Proxima Centauri could be limited to just 1 century. That's not all the ideas. What do you think about microprobes? A project called Breakthrough Starshot proposes sending a swarm of tiny probes to the cherished goal, traveling at a speed of 20% of the speed of light. Their momentum will be provided by clusters of ground-based lasers. If the project became a reality, we would receive data about the planetary system of Proxima Centauri in the first half of this century. But the information would take a long 4 years to reach us. Considering the fact that humanity already has more than enough problems on Earth, is it worth moving in this direction and continuing the search for potentially habitable exoplanets? Scientists are certain it is. Before the first telescopes were invented, people's ideas about what planets and other cosmic objects looked like were based only on assumptions and, of course, a rich imagination. Now it's a completely different time. We have advanced technologies that allow us to get accurate information. Now we have plenty of images of the universe, including the sun and various planets. Now let's take a look at some amazing footage that blows the mind. The sun can be considered a huge, powerful bomb in our planetary system. Every second, it releases as much energy as 1 trillion nuclear bombs. Our main star makes up more than 98% of the total mass of the solar system. Amazing images of the sun were taken by one of National Aeronautics and Space Administration's space observatories called the Solar Dynamics Observatory. This happened relatively recently in August of 2021. At that time, they managed to capture a truly unique moment. It looked as if a small part of the sun's material separated and remained motionless for a while. This very dangerous mass ejection, after hovering, moved at a speed of 1,448 kilometers per second. As is known, Mercury is the closest to the sun. It, like the main star, has always been of special interest to researchers. The Messenger space probe became the first spacecraft to enter Mercury's orbit. There, we were able to see the planet's surface, which was covered with craters of various sizes. We can clearly see the sites of asteroid impacts as well. For example, the Van Eyck crater is among them. Now take a look at these images, dated April 2015. Here we see the spectral measurement of Mercury's surface. In total, the Messenger probe was able to capture about 200,000 images of Mercury from different angles, many of which are in high resolution. After completing all its assigned tasks, the spacecraft crashed into the surface of the planet. Of course, this was intentional since Messenger simply didn't have enough energy to return to Earth. You might think that Mercury is the hottest planet in the solar system, since it's the closest to our main star. However, there are planets with significantly higher surface temperatures, and that's Venus. It's also the planet that's closest to Earth. Venus has its own atmosphere. Its layer is 90 times thicker than Earth's. It's mostly made up of carbon dioxide. Venus has hellish surface temperatures because of its atmosphere. The Soviet Union's development, Venera 13, was specifically designed to study the planet. On March 1, 1982, the spacecraft became the first to take color photographs of Venus and send them back to Earth. The temperature on the planet's surface reaches 470 degrees Celsius. The module itself was designed to operate for about half an hour. However, it was built as a kind of reservoir, which helped maintain its efficiency for 2 hours after landing on Venus. In 1990, a National Aeronautics and Space Administration spacecraft called Magellan was sent to this planet to capture images of the entire surface. As a result, we obtained evidence that Venus has volcanism, tectonic plate movement, the effects of winds, as well as kilometers of lava trails. One such lava trail is almost 8,000 kilometers long. And now take a look at another unique image of the highest volcano on Venus, 5 kilometers tall, Mount Mott. At the end of its mission, Magellan, like many other spacecraft, simply crashed into the surface of the planet. As you know, the third planet from the Sun is Earth. It is the only planet in the solar system that has life. I think you won't be surprised by just a photo of our planet from space, but we'll try. Take a look at this photo of Earth taken by a more modern National Aeronautics and Space Administration telescope in high resolution from a distance of 35,000 kilometers. We can see North and South America as well as the Moon, which happened to be in the frame. And 2 years ago, National Aeronautics and Space Administration managed to capture a total solar eclipse using the Geostationary Operational Environmental Satellite 16 satellite. But that's not all. Back in 2011, the Electro-L satellite took another detailed photo of the Earth, this time showing Africa and Eurasia. What about Mars? This amazing planet has fascinated scientists for many years. It's also called the Red Planet. In 1979, the Viking 1 spacecraft was sent to Mars. As a result, we have many detailed photos of the planet, like this one. After Viking 1, Viking 2 was sent to Mars, which captured the southern polar plains and the polar ice caps. In 2013, the European Space Agency provided many detailed images of Aechus Chasma, a fissure in the high plateau of Lunae Planum, which is also the northernmost part of the Mariner Valley. We also have images of Mars from other spacecraft. For example, from Curiosity, which provided panoramic images of the planet made up of other photos. Let's move on to the largest planet in our system, Jupiter. It stands out from other planets due to its size and its great red spot. This is an atmospheric vortex that, over all the years of observation, has periodically changed both its shape and its color. The Great Red Spot's diameter is larger than Earth's, which is remarkable. 5 years ago, the spacecraft Juno flew at a distance of 9,000 kilometers from this atmospheric vortex. As a result, we have an image of the Great Red Spot taken from the closest possible distance. Juno didn't stop there and took photographs of Jupiter's polar regions. The uniqueness of these photographs lies in the fact that these are the very regions we can't observe from Earth. Researchers were amazed by the fact that there are 8 vortices in the northern part of Jupiter, which are constantly rotating. In November 2018, Juno provided a new breathtaking photo. Just take a look at this. 3 years ago, in June 2019, with the help of the Hubble telescope, we received another image with the Great Red Spot, which according to researchers is shrinking in size. Now let's move on to Saturn. Thanks to its remarkable rings, you can't mistake this planet for any other. We have the most famous images of Saturn thanks to the Cassini-Huygens Automated Interplanetary Station. In 2002, this image was taken at a distance of 285 million kilometers from the planet itself. Just 2 years later, we received a new image, but this time from a closer distance. And here's a photo of Saturn that you may not have come across on the internet yet. This is the moment of a solar eclipse by Saturn. We also have a unique image of Saturn's northern hemisphere. It shows hexagonal vortices, the nature of which scientists did not yet understand. 5 years ago, in 2017, Cassini was nearing the end of its mission. It was assumed that the spacecraft would simply burn up, but before that, we received an image of Saturn's surface from a very close distance. Uranus is the 7th planet from the Sun. Voyager 2 took a picture of this planet in 1990. The photo was obtained by using 3 color filters. In July 2004, using the Keck telescope, another image of Uranus was created where its rings are visible. Here we can also notice a bright spot. Uranus was also imaged by Hubble. We obtained a color photo where a distinct red tint of the rings is visible. Already in 2017, the telescope also captured bright spots on Uranus. And now let's move on to the 8th planet from the Sun, Neptune. Because of this distance, the only spacecraft that managed to get close to the planet was Voyager 2. Take a look at this photo. Here you can see a massive storm. Voyager 2 was intended to continue its mission already in interstellar space. But before that, it took an image of Neptune's surface from a very close distance. You can see bands of atmospheric clouds in it. The Hubble telescope also provided us with relatively recent images of Neptune from the year 2020. Here you can notice a huge dark spot. Even though Neptune is far from Earth, the Southern European Observatory, using the narrow-field mode of the adaptive optics spectrograph, was able to capture an image of Neptune taken from our planet. And now, let's move on to the most controversial celestial body on our list, Pluto, which is no longer considered a full-fledged planet of the solar system. It is regarded as a dwarf planet. In July 2015, New Horizons provided us with a color image of Pluto. This picture was created by combining 3 other images, red, blue, and infrared. We also received other high-quality images of Pluto from New Horizons, where we can see mountains covered with ice. Its moon, Charon, was also captured. We have not yet received images of many cosmic objects in the universe that are of particular interest to the scientific community. However, right now, we can definitely enjoy the images of the planets in our solar system. I think you've heard this statement many times. In the endless expanses of the universe, there must be celestial bodies in every region. This is the photometric paradox. There is also a paradox with an interesting name, the paradox of heat death. When a state of thermodynamic equilibrium is reached, the stars in the universe disappear. And there is another amazing paradox. It's called the red sky paradox. We don't know much about it. They only started writing about this paradox in 2020. Scientists are pondering why the star in our system is not a red dwarf. Most likely, this intriguing explanation has only confused you. So, make yourself comfortable. We are going to figure out what this paradox is all about. Our planet is unique because it is the place where intelligent life originated. The scientific community is trying to figure out what factors contributed to this. The main star in our system, that is our sun, played a significant role in this. It belongs to the class of yellow dwarfs. Our star can be considered unique in some ways. Since most, about 85% of similar stars in the universe are red dwarfs with a relatively small mass, which can be up to half the total mass of the sun. At the same time, their lifespan is longer than that of yellow dwarfs. We know about planets located near red dwarfs where life could potentially arise. Since red dwarfs exist much longer, they can provide a longer lifespan for a habitable planet. In this case, the question of why our sun is not a red dwarf becomes extremely interesting for us. This is the essence of the red sky paradox. Of course, we might think that the yellow dwarf in our system is just a coincidence. However, it's not that simple. What if this particular class of dwarfs turned out to be more favorable for the development of our planet? Yes, most stars belong to red dwarfs, but what about the stars that are close to us? The trend remains the same. We see stars that belong to this class. It turns out we're actually surrounded only by them. And the most amazing thing is that being on Earth, we can't see a single such star with the naked eye. But how is that possible? The answer here is quite simple. Red dwarfs are small in size and their level of brightness is quite low. Thus, in the night sky, we don't see all the stars, even though it sometimes seems to us that it's the other way around. It's just that the glow of some stars isn't bright enough for us to see them from Earth. And while groups of some stars are being born and dying, red dwarfs continue to live. According to scientists, stars of this class haven't lived long enough yet to complete their life cycle. Usually they die, for example, during collisions with another celestial body. Otherwise, even the oldest stars of this class still exist. As we go through our story, you might have a reasonable question. Here we are talking about some stars. But the phenomenon we're discussing is called the red sky paradox. So why is it exactly like that? Would the color of our sky really change if, instead of the sun, we had a red dwarf? Actually, no. Even though the sun is classified as a yellow dwarf, it doesn't make our sky look yellowish. And in most cases, our star itself actually looks white to the naked eye. So we're talking here about the range of colors visible to us. Generally speaking, the color of a star depends on its temperature. Orange stars have the lowest values, while blue ones have the highest. The question of determining a star's class is not always straightforward. In some cases, the shade may be slightly different, so the star is assigned to a separate group within a certain class. For example, if we looked at Proxima Centauri, which belongs to the red dwarfs, up close, it would appear more orange than red to us. Accordingly, you shouldn't take the names of star classes too literally. So what affects the color of the sky? A lot depends on the atmospheric layer here. The color is shaped by a combination of factors, so we can't talk about drastic changes just because there's a red dwarf as the main star. First, we discussed a solution to the red sky paradox. However, in that case, we didn't take into account the probability of life emerging on planets with red and yellow dwarfs. By default, it was the same for all planets. In reality, the probability of life emerging on planets whose main star is a red dwarf is much lower than with other classes of stars. We have fairly strong evidence for this. The activity level of young red dwarfs is much higher, which leads to more flares. This prevents life from emerging on nearby planets. Due to the lower temperatures of this class of stars, the zone where water can exist in liquid form is quite small. If a planet is very close to such a star, it is highly likely to become tidally locked. In other words, it will always have the same side facing the star. And you understand that under such conditions, the normal development of life on the planet is out of the question. For the same reason, red dwarfs practically have no giant planets. Why is this important? The thing is, having a giant planet in the system has a positive effect on habitable planets. For example, with their size, they protect the planet itself, stopping meteorites and other celestial bodies. Thus, all of this doesn't interfere with the development of life. To sum up what was said above, we can recall the scientist David Kipping, who claimed that the probability of a habitable planet forming in a red dwarf system is 100 times lower than in systems with other types of stars. It should be noted that we cannot call this information accurate, since much is still unknown and requires further research. There is another solution to the red sky paradox. It is called the narrowed window for complex life. The point is that life on a planet near a red dwarf simply hasn't had time to appear. It hasn't had enough time. Despite the fact that stars of this class are the longest living, the decisive role here is played by the so-called pre-main sequence star, or pre-main sequence star for short. This is a phase in a star's life cycle that occurs before the period when the star begins to fuse hydrogen. Such stars can also have a strong magnetic field. Their brightness level can also be higher than in the next phase. The most important thing is that the duration of the pre-main sequence phase for stars can reach up to 1 billion years. What happens to planets that are located near such a star? In places where life could potentially emerge, a constant greenhouse effect occurs. As a result, the surfaces heat up to temperatures at which the existence of living organisms becomes impossible. Yellow dwarfs, including the Sun, also have such a phase, but its duration is significantly shorter. During this time, life could still develop on a planet in the habitable zone. But the last possible solution to our paradox is the small number of pale red dots. Most often, the objects of observation are the dwarfs with the largest masses, since their brightness level makes research easier. The results show that about 16% of the studied red dwarfs have exoplanets in the habitable zone. The catch is that less massive red dwarfs are not well studied, and accordingly, there may not be such planets in their habitable zones. Considering this fact, we can assume that the probability of having rocky planets in the habitable zone of a red dwarf is 100 times lower than that of yellow stars. Accordingly, life rarely originates there. As technology develops, we will have the opportunity to study red dwarfs even with a small mass. This will help us determine more precisely whether there are exoplanets near them. Then we will have the opportunity to assess how likely it is for life to originate on them. The red sky paradox will probably become the main subject of research in the future. And that's not surprising, because this will help us find out how likely it is that habitable planets exist in the universe. This is the next generation space telescope, James Webb. All enlightened humanity eagerly awaited its debut. At the moment, this is the most productive optical device ever launched by humans. What tasks is this innovative telescope supposed to accomplish? What equipment is it equipped with? What photos has it already sent to Earth? And why couldn't we just stick with the familiar and proven Hubble? We'll try to answer all these questions briefly, clearly, and concisely. The launch of the James Webb Telescope, which took place on December 25, 2021, went off without a hitch. You could chalk it up to luck, which favored the employees of National Aeronautics and Space Administration, as well as the European and Canadian space agencies that day. Or you could draw the obvious conclusion that over the years, we have actually learned how to organize such events properly. In any case, the Ariane 5 Evolution Cryotechnique Type A rocket launched the telescope to the required altitude with the necessary acceleration and at the right angle, after which the spacecraft set off on a long 30-day journey to its orbit, to the Lagrange point L2, where it will be able to operate successfully for many years, monitoring the most distant corners of the universe. Although James Webb has already arrived at its destination, it will take several more months before it is fully operational. Therefore, most likely, the telescope will only be launched in the summer of 2022. Before then, all 18 telescope mirror segments must be calibrated to work as one large mirror, and the equipment cooled to nearly minus 270 degrees Celsius, a process that will take several weeks. First of all, let's answer the question of why humanity wasn't satisfied with the rather effective tool called Hubble, which has served us faithfully for more than 30 years. The main secret lies in the observation range. While Hubble sees the universe in the near ultraviolet and infrared spectra, James Webb will observe in the range from long wave to mid-infrared. What does this mean in practice? The new telescope will look into places where the first stars and galaxies were formed, places no Earth-based device has ever seen. The second advantage James Webb has over Hubble is that it won't be hindered by Earth's atmosphere, so its optical resolution will be 10 times greater. What tasks is James Webb designed to accomplish? First and foremost, it will focus on the regions where, according to the traditional hypothesis, the Big Bang occurred. It is there that scientists hope to detect the first light of the universe, which has traveled for billions of years from stars and galaxies. James Webb will also take a closer look at star systems for the presence of exoplanets, where it may be possible to detect life in any of its forms. The amazing yet advanced telescope will even be able to see the moons of such planets. The only thing James Webb is not capable of is obtaining images of the discovered objects. This will become possible around the 2030s when humanity launches the Large Ultraviolet Optical Infrared Surveyor spacecraft. Next, Webb will focus on the process of galaxy formation, from the oldest ones to those that appeared approximately 400 million years after the Big Bang. So far, no telescope has managed to accomplish this task, again, due to the inability to see in the infrared range. But what about our star system? Is James Webb really going to ignore it? Of course not. The telescope will closely study the moons of giant planets, where oceans are thought to rage beneath their crusts. We're talking about Europa and Enceladus. James Webb will also study the small bodies of the solar system in detail. Moreover, at the Lagrange point L2, neither the Earth nor the Moon will interfere with it, since they will be positioned behind the spacecraft. What equipment installed on board James Webb will help to reliably accomplish the above-mentioned tasks? Engineers equipped the telescope excellently. No wonder nearly $10 billion were invested in the project. At first glance, the spacecraft's heat shield seems fragile, but it is made of durable captain with aluminum and silicon coatings, capable of withstanding temperatures from absolute zero up to plus 400 degrees Celsius, which is comparable to the stifling climate of Venus. In addition, the multi-layered material will prevent meteoroids from causing significant damage to the heat shield. In any case, thanks to special seams, any punctures will not grow to dangerous sizes. Of course, the most important component of the telescope is the segmented mirror, which has a diameter of 6.5 meters. They immediately abandoned the idea of creating a solid object of that size, because due to its incredible weight, no rocket would be able to launch James Webb into orbit. That's why astrophysicists turned to a Pentagon project designed for reconnaissance satellites. As a result, the telescope was equipped with a segmented mirror. The drawback of such a gadget was the gaps between the cells, but in practice, the errors turned out to be insignificant. But do you know what's most amazing? It's the micromechanics of the beryllium mirror, which allows it to be adjusted with an accuracy of up to 140 nanometers. And that's about the size of the human immunodeficiency virus. By the way, this technology is still classified by the National Reconnaissance Office of the United States. As for the rest of the equipment, the telescope is mainly equipped with several types of spectrographs, a fine guidance sensor, and a near-infrared camera, capable of detecting the light of the most distant stars, studying Kuiper Belt objects, revealing the mysteries of galaxy formation, and even creating a map of dark matter. Spectrographs, in turn, are essential for studying objects that emit critically low amounts of light. To monitor up to 100 such objects simultaneously, a unique microshutter system was created to suppress the light from brighter sources. And now for the most interesting part. What photos did the James Webb Telescope send to Earth? Don't be surprised. Though not yet operational, the telescope has already briefly pointed its lens into deep space. First of all, it's a selfie of the telescope itself, or rather its main mirror. This photo clearly demonstrated to the engineers how well the segments are aligned and what still needs to be worked on. The next target for James Webb was a star called Henry Draper, 8406, located in the constellation Ursa Major. In terms of its characteristics, it is similar to the Sun and is located at a distance of 260 light-years from us. Project supervisors chose this object because no bright stars nearby would interfere with observations. Thanks to the photographs obtained, the scientists concluded that the camera is working correctly, and also decided in which direction to proceed regarding further adjustment of the mirrors. It is noteworthy that the image was obtained as a mosaic of 18 parts, since at the moment the mirror is functioning as separate segments. Which objects will the telescope observe after its segments are fully calibrated? These will be the planetary systems of Eridanus and HR 8799. Regarding the first one, we know that near a young star in the constellation Eridanus, about 20 million years old, and located almost 100 light-years away from us, at least one planet orbits it, which belongs to the brown dwarfs. So, what is the planetary system of HR 8799 like? It is located in the constellation Pegasus at a distance of almost 130 light-years from the Sun. It is believed that the three-planet system is supposedly shrouded in a dust cloud similar to the Kuiper Belt. One of the objects was photographed by a Chilean telescope, and it turned out to be a giant 10 times more massive than Jupiter. The outer layers of the celestial body's atmosphere are quite hot, plus 800 degrees Celsius. So James Webb will take a closer look at these systems as early as July, measure the spectra of the planets, and study the composition of the dust cloud in detail. Right now, the telescope is 1.5 million kilometers from Earth, carefully calibrating its research instruments for productive work and gradually cooling down. The fuel stored on board the spacecraft should theoretically be enough for 20 years. Initially, it was calculated for 5 to 10 years of uninterrupted operation, but a successful maneuver during launch allowed for some savings. Considering the location of the spacecraft, at the moment there is no talk of any manned mission for refueling or repairing instruments that may fail during this time. This isn't Hubble, which had shuttles sent to it multiple times. Therefore, engineers are not making any predictions yet about how long James Webb will operate. What does the world expect from this scientific pioneer? Astronomers plan to use it to discover incredible things and to look into such distant corners of the universe that they never even dreamed of. And we will closely follow the work of James Webb and hope that it will last as long as Hubble. The age of our planet is quite significant, 4.5 billion years. In theory, Earth can exist for about the same amount of time again. However, many factors affect its lifespan. For example, the sun. The processes happening there can cause a temperature increase that will create conditions impossible for humanity to survive. The destruction of the planet itself is a completely different matter. If, for example, a black hole enters our solar system, then our planet will simply break into several pieces. A meteorite could crash into Earth, causing the extinction of all life. About 66.5 million years ago, a 10-kilometer wide asteroid caused a mass extinction and wiped out the dinosaurs. We also can't rule out the danger that our planet could go off its orbit. If you think about it, our planet is absolutely defenseless in this vast universe. However, even if we set aside all possible cosmic threats, there is a completely unexpected force capable of destroying our world. Have you heard about the false vacuum theory? Why is it called false? There is a theory that the vacuum in our universe is not real, and at some point could become true. This process is called the decay of the false vacuum. It leads to the destruction of the universe in its usual state. To better understand this process, let's figure out what the vacuum in the universe actually is. It's actually impossible to create a vacuum artificially. We can't pump all the air and all the atoms out of a space, but some parts of the universe are as close as possible to a perfect vacuum. Most likely you can find it in intergalactic space. There, it's empty in the usual sense, and often there are no atoms of ordinary matter. It's known that we can't create absolute emptiness by removing all particles from a part of space. According to quantum theory, there are fields in the universe whose values change over time and depend on location. Under the influence of different energies, fluctuations occur in the area of these fields. Even if they stop, the fields will still remain. So even if the energy level of the fields is minimal, the term absolute emptiness won't be accurate in this case. Heisenberg's uncertainty principle states that even at low energy levels, small fluctuations, known as quantum fluctuations, still occur. In a small region of space and over a short period of time, pairs of particles appear and disappear. The existence of quantum fluctuations is also confirmed by the so-called Lamb shift. It was previously assumed that electrons in a hydrogen atom, which were on the 2p and 2s energy levels, had the same energy level. However, it was experimentally proven that this is not the case. This feature was named the Lamb shift. After some time, this phenomenon was explained. It turned out that there was an interaction between the electron and quantum fluctuations. It's also worth mentioning the well-known Casimir effect. As we know, field fluctuations occur even at minimal energy, as stated by quantum field theory. As a result, virtual particles appear. If we're talking about the electromagnetic field, then virtual photons arise here, whose waves have all possible wavelengths. 4 years ago, an article appeared in a scientific journal stating that scientists attempted to obtain an image of the effect of quantum fluctuations using a scanning microscope. During further experiments, it was found that quantum fluctuations affect even objects of minimal size. It is logical when discussing the vacuum to also touch upon such a phenomenon as dark energy. It is precisely because of it that the universe is rapidly expanding. We still haven't figured out what exactly it is. By the way, we have a separate video about it, but we can observe the consequences of its existence. The phrase energy of space itself is often mentioned when talking about dark energy. This can be related to vacuum energy. It's quite possible that this is how the nature of dark energy can be explained. However, it's not all that straightforward. If we take a single virtual photon, it doesn't play a significant role in increasing the vacuum energy. But the effect becomes noticeable if we sum up the energy of all virtual photons. Thus, even in a relatively small region of space, there will be a significant level of energy. To provide for the expansion of the universe, the amount of energy needs to be 120 orders of magnitude less. And what do we mean by the term false vacuum? We simply call vacuum the state in which the field has the lowest possible amount of energy. A system in a vacuum is characterized by stability. You could say that the universe works to reach a state of stability and reduce the amount of energy. If it's no longer possible to lower the energy, then this phenomenon can already be called a true vacuum. However, how would we characterize a situation where particles are in a stable state, but the energy can still be lowered? This is exactly what is called a false vacuum. It's a state of a quantum field that corresponds to its local minimum. Is it possible that certain parts of the universe are not in the true vacuum, but in the false one? If this is really the case and the energy level hasn't reached the minimum yet, what will happen to chemical reactions and objects in the universe as it decreases? The universe will undergo significant changes when transitioning to the state of true vacuum. This could lead to the destruction of stars and planets along with their satellites. Right now, we're only talking about assumptions, but what is it really like? Is the universe really in a false vacuum? There is such a possibility. I think you've probably heard something about the Higgs field. Most fields have a minimum energy level in a true vacuum, but for the Higgs field, as scientists suggest, instability is characteristic. This field's expected average vacuum value is not zero. It is the Higgs field that can exist in a false vacuum. It has a special barrier that stops the energy from falling and prevents the transition to the true vacuum state. The field can remain in this state for quite a long time, but if any forces act upon it, the energy level will start to fall. In that case, the aforementioned transformations will occur in the universe. So, what is the probability of such an outcome? It is possible, and here's why. We can learn about the stability of the vacuum by comparing two particles, the most massive T-quark and the Higgs boson. We now know the masses of both particles. Taking these values and the uncertainty into account, we can assume that the vacuum is characterized by metastability. According to this data, it means that we can safely exist in such a universe in a false vacuum state for a very long time. But if the decay of the false vacuum suddenly happens, what could contribute to it? We have two versions. Since stability currently reigns in the universe, to change the state of the vacuum, energy needs to be involved. If, for example, a powerful explosion occurs somewhere in the universe, a region with true vacuum will form. It will gradually begin to expand and occupy a significant part. However, such a phenomenon would require a huge amount of energy. That is why scientists do not believe that something like this could actually happen. With quantum tunneling, it's a whole different situation. Particles usually don't pass through obstacles, but if you rely on quantum mechanics, it's quite possible. Thus, a region with true vacuum will be created in the universe. If the size of this region is very small, it doesn't necessarily start expanding, but the probability of the opposite still remains. During the decay of the false vacuum, nucleation can occur, meaning a change of state that starts because of a small region that appeared due to quantum tunneling. In that case, the transition of the universe to the true vacuum state will happen gradually. Since different laws operate in the newly formed region, it will destroy everything in its path. Such an event will most likely happen sooner or later. We don't know exactly when. Scientists have different opinions about this. It's possible that quantum tunneling has already happened somewhere, considering the size of the universe. In any case, it won't reach our galaxy anytime soon. If this region has already formed somewhere and is beyond the event horizon, then it will never reach our planet. After all, as we know, the universe has a tendency to expand. So there is no reason to expect the end of the world. And if the vacuum of our universe is not false after all, then such a fate will not befall us at all. Further research will definitely shed light on this question. Take a look at the screenshots that are on the screen right now. This is YouTube's statistics. What does it mean? Notice that right now, 57% of this channel's viewers are watching without subscribing. This is the true essence of my message to you. So, in order not to miss out on Hubble from your subscriptions, all you need to do is click on this red button, which looks like this and is located below this video. The law of the universe is simple. Remember that, because every subscription from you is very important to me. The more viewers there are, the more often they watch and hit the like button, the faster a new mega exciting video comes out. Talk to you soon.